Our first step in the procedure is to solve the inequality for y. We're to get y by itself. Well, y is by itself, and so that part has been taken care of in this problem. Our second step is to find the boundary line. For the boundary line, we replace the inequality symbol greater than with equals. So our boundary line is y equals 2x minus 1. The boundary line is y equals 2x minus 1. The third step in our procedure is to graph the boundary line. We will draw the boundary line as a dotted line because the inequality symbol is simply greater than. It does not have the equals part. So our task is to graph y equals 2x minus 1. We make our table of values, and the values I've chosen for x are -1, 0, and 1, just to get easy values. So we fill in -1 in place of x, and we get y equals 2 times -1, subtract 1. 2 times -1 is -2. -2 subtract 1 will be -3. So the y is -3. That gives us the point -1, -3. Filling in 0, we have y equals 2 times 0, subtract 1. 2 times 0 is 0, 0 subtract 1 is -1, and so we have y equals -1. Then filling in 1, y equals 2 times 1, subtract 1. That gives us 2 subtract 1, which is 1, and so our third point is 1, 1. So we have the 3 points, -1, -3, 0, -1, and 1, 1. Let's go to the graph and put these 3 points on the graph. The first is -1, -3. So here's my graph, and I choose -1, -3. So that means I count to the left 1 and down 3. -1, -3. The next point is 0, -1. Start at the origin, count none sideways and down 1. So there's 0, -1. And then the point 1, 1. Start at the origin, count 1 to the right and up 1. The 3 points do line up, and so I can draw the boundary line. Now at this stage, you would put back into focus the original, which says y is greater than 2x minus 1. Y is greater than, that means we do not use the boundary line, and so the boundary line is drawn as a dotted line. So I'll put my ruler down with these 3 points and draw a dotted boundary line. A dotted boundary line. A dotted boundary line. The line, as always, is infinite, even though it is dotted, and so the arrow points on each end indicate so. Next, we shade above the boundary line for greater than, below the boundary line for less than. The original inequality was y is greater than 2x minus 1. Let me write that inequality down beside the graph so we won't have to keep sliding back and forth. We're graphing y is greater than 2x minus 1. Y is greater than 2x minus 1. Greater than goes up, less than goes down. The greater than means we go up above the boundary line, and so we'll shade in all the portion that is above the boundary line. Now, I've shaded in freehand and rather sloppily, but this is to indicate that all of the area above the boundary line is shaded. Can you look at this graph and tell at a glance which part is shaded in? If you can, then the graph is sufficient. If you cannot tell, then you've got to make it absolutely clear. So here's what I'm assuming is the correct graph for y is greater than 2x minus 1. But remember, we can check by choosing a point above the boundary line and a point below the boundary line. Any point above the boundary line would do. We could use this point because that's above. We could use this point because that's above. This one, 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 this one. There are infinitely many that we can use. We'll simply choose something that seems easy. Well, the easiest point on the whole graph is the origin. Are we absolutely certain that the origin is not on the boundary line? It seems clear enough that the origin is not on the boundary line. It is rather close in this example, but it seems clear that it is not on the boundary line. And so I'm going to choose 0, 0 for the point above this boundary line. So we're checking y is greater than 2x minus 1. The point that is above will be 0, 0. The x value is 0, the y value is 0, so when we fill in the values for y, we fill in 0, and for x, we fill in 0. And so we get 0 is greater than 2 times 0, subtract 1. On the left, we have just 0, then the greater than. On the right, 2 times 0 is 0. 0 subtract 1 is negative 1. 0 greater than negative 1 is true. And so the 0, 0, which is above the boundary line, tests true. And remember that the true is supposed to go with the part that is shaded. 0, 0, the point I've tested, is on the shaded side, and it does test true. For a point below the boundary line, just as a double check, let's choose any point below the boundary line. I'm going to choose this point. Let's see what its coordinates are. To the right, 1, 2, 3, 4, up 2. So I'm going to test the point 4, 2 to see whether it tests correctly. Remember that on the unshaded side, the test should come out false. So let's go back to our page where we're working on the check. Below, we'll use 4, 2. And we're testing y is greater than 2 times x subtract 1. The y value is 2. The x value is 4. And so we have 2 is greater than 2 times 4 subtract 1. This gives us 2 is greater than 2 times 4 is 8. 8 subtract 1 is 7. 2 greater than 7 is false. And so we got a false statement for the part that is unshaded, which is correct. That means that my graph was correct. The true and the false came out as they should.